Hi, my name is Zati Bayani, Zakirah Binti Hasnul Basri with Matrics Number 281447. In this video, I will be presenting how I solved my question 1 in my individual assignment Calculus 1. So, let's get started.
The question that I get is, discuss and sketch the following function fx equal to x to the power of 5 minus 5x to the power of 3. Before we sketch the following function, we need to find x-intercept, y-intercept, open interval where the function is decreasing and increasing, x-coordinate of the inflection point, open interval where the function is concave up and down, local minima and maxima, and then we can sketch the graph of the function. First, we need to find the x-intercepts. So to get the x-intercept, we need to set fx equal to 0, and then we can factorize it and we'll get x equal to 0, x equal to square root of 5, and x equal to negative square root of 5. In conclusion, the x-intercepts are at 0, 0, negative square root of 5, 0, and square root of 5, 0. Next, we will find y-intercept. To get y-intercept, we need to substitute x to 0. So, substitute x equal to 0 into the function and we will get 0. So in conclusion, y-intercept is at 0, 0. To know where the function is increased and decreased, you have to find the first derivative of the function and get as below. And set the first derivative of the function equal to 0 to get the critical point. So we got the critical point as x equal to 0 and x equal to positive square root of 3 and x equal to negative square root of 3. So based on the theorem, we know that the function is increased when the first derivative of the function is more than 0 and decreased when the first derivative of the function is less than 0. And we know that x equal to 0 and negative square root of 3 and square root of 3. So we break the real number into the interval between the roots and do in a table, and we get the open interval of the function is like this. To get the x-coordinate of the inflection point, we need the second derivative of the function and we will get 20x to the power of 3 minus 30x. And then we can set the second derivative of the function equal to 0, and then we can factorize it as usual and we will get x-coordinate equal to negative square root of 3 over 2, 0, and square root of 3 over 2. To know where the function is concave up and down, we have to know the theorem. So the second derivative of the function is bigger than 0, so it will concave up, and the second derivative of the function is less than 0, it will concave down. We know that the second derivative of the function equal to 0 at negative square root of 3 over 2, 0, and square root of 3 over 2. So we break the real number into the interval between the roots and do a table like this, and we'll get the open interval will concave up and down like this. Before we go to find local minima and maxima, we have to know that sum of theorems. So we have to know that x equal to c is a critical point of the function. These are some of the guidelines to know where is local maximum and where is local minimum. So let's go to find the local maximum and minimum of the function. As the theorem before, we know that we have to find the x1 and x2 of the points. So for negative square root of 3, I got x1 is negative 2 and x2 is negative 1, and I substitute it in the first derivative and get f prime x1 is more than 0 and f prime x2 is less than 0. To know that it is a local minimum or maximum, I substitute the negative square root of 3 into the function and get 10.3923. So based on the theorem before, we know that it is a local maximum. So on the other point, I do the same thing and get 0 as no local maximum and minimum, and the local minimum is negative 10.3923. After we find all the points, and these are the points that we get, then after that we can sketch the graph of the function. So this is the sketch of the following graph that we get based on the points that we find before. So that's all from me. Thank you and bye.